Okay, in this second part of the video, we're now going to learn how to solve mole problems that involve concentration. Now, you can see a flowchart on the screen. The top row of the flowchart you've seen before. That's the flowchart that we were using when we were solving mass-to-mass problems. So if we knew the mass of one of the substances and we had to work out the mass of one of the other substances in the equation. Now what we can do is we can add extra branches to this flowchart because we've got an additional equation that we can use to work out the number of moles. Okay, so we're going to see how that works. This is the first problem that we're going to solve. In this case here, the problem tells us that Josie placed 20 milliliters of 0.524 moles per liter lead nitrate solution into a test tube. She added excess potassium iodide solution, a bright yellow precipitate formed, and the precipitate is lead iodide. And we've got to calculate the mass of potassium iodide that is formed. Okay? Now, so we've been provided with a volume and a concentration, and we've got to work out a mass. So, in other words, we're going to start over here, where we've got the concentration and volume of one of the substances, and we're going to end up over here. So that's the path that we are going to follow. Okay, so step number one, I'm going to work out the number of moles of, actually before we do that, I'm actually going to write an equation. Okay, so we can see what's actually happening. So we've got lead nitrate reacting with potassium iodide. It's a precipitation reaction, so they swap partners. So the products are going to be lead iodide and potassium nitrate. Okay, and the question tells you which one is the precipitate. Now that equation is not balanced, so I'll quickly balance it now. Okay, so that's the equation. So when we're solving this type of problem, it's always a good idea to start as your first step by writing an equation. Okay, now I can go back to the flow chart. So first step is to work out the number of moles of the substance that I've got enough information to work out the number of moles. And in this case, I've got the volume and concentration of the lead nitrate. So that's the one that I've got enough information to work out the number of moles. So the number of moles of lead nitrate is going to be C times V. So concentration was 0.524. The volume is 20 milliliters, which is the same as 0.02 liters. When we put that in a calculator, that works out to be 0.01 moles. Okay, I've done this step over here. Next step is this one. I use the equation to work out the ratio of the substance for which I know the number of moles compared to the one that I'm trying to work out. Okay, so the ratio of lead nitrate to lead iodide. So if I look at this equation over here, the ratio of lead nitrate to lead iodide is 1:1. Okay, so since the ratio of lead nitrate to lead iodide is 1:1, what that means is that the number of moles of lead iodide is going to be the same as the number of moles of lead nitrate. Now note that I've written 0.01 moles on the screen. The actual answer has got many more decimal places than that, and that's the value that I've stored into my calculator. I'm not going to round off at this stage. Okay. Next step is to work out, so I've done this part of the flowchart, I've done this part of the flowchart, and this is where I want to end up. Okay, so the next part of the flowchart is to work out the mass of lead iodide, and I'm going to use the equation that mass is the number of moles times the molar mass. So mass of lead iodide is going to be the number of moles, which I just worked out to be 0.01, times the molar mass of lead iodide. Again, I'll need to use my periodic table. So it's going to be 207.2 plus 2 times 126.9. That works out to be 4.83 grams. Okay, and then if we look at the question, the two values given to me in the question have got 3 significant figures, so I've given my answer to 3 significant figures. Okay, the next example, this time we've been given the mass of one of the substances, and we've been asked to work out the concentration of the other substance. Okay, so in other words, we're starting over here, and we've got to work out a concentration. So we are going to follow this path over here. Okay, so first step is to write an equation first of all. So we've got sodium reacting with water. Now when a metal reacts with water, we get a hydroxide and hydrogen gas. To balance this equation, I'll need a 2 here, a 2 here, and a 2 here. Alright, so the next step, I want to work out the number of moles of sodium. And the equation that I'm going to use is mass over molar mass. So the mass is given to me in the question is 3.12 grams. And the molar mass of sodium is 22.99. I've looked that up on the periodic table. So that works out to be 0.136. Okay, next step is I've got to use the equation to work out the ratio of sodium to sodium hydroxide. So if I look at the equation, sodium and sodium hydroxide both have a 2 in front of them. So that means that they are in a 1-to-1 ratio. Okay, so that means that the number of moles of sodium hydroxide is the same as the number of moles of sodium, so it's 0.136 moles. Okay, and then the last step is to work out the concentration, and I'm going to use the formula C is N over V. Now, one thing I should mention as well is that in chemistry there's a shorthand symbol for concentration. We use square brackets. So that means the concentration of sodium hydroxide. It's just a shorthand way of writing it down. So it's going to be N over V. N we've just worked out to be 0.136. And the volume is given to us in the question is 250 milliliters, which is the same as 0.25 liters. So that works out to be 0.53 moles per liter. Okay, so now you need to get lots of practice at these types of problems. Start out using the flow chart, but remember that eventually when you're answering exam questions, you won't have the flow chart available. So you need to make sure that you start out with the flow chart, but get used to eventually solving this type of problem without the flow chart in front of you.